It's Monday night again. It's time for Let's Make It. And this week, Bob is going to dig into some XPs to put together some viewer requests. Coming up right after this. Hello and welcome to another episode of Let's Make It. This one was episode number 52, recorded on the 4th of February. I think it's 4th? 3rd of February. Sorry, Monday, the February 3rd at 9 p.m. And this week, in our second segment, Bob's going to take us through some viewer requests. But before we get into that, I have a couple things that I want to cover. First of all, I want to say thank you to everyone who has bought anything through our Amazon link. That's definitely appreciated, and we really love you for doing that. We also want to say thank you for telling your friends about it. The show is growing quite quickly, and it's all because of you, because you're out there sharing our show with your friends, and that's definitely appreciated. If you are watching us on YouTube or you're getting us to a download, we would definitely appreciate you giving us a rating that helps us get found. That's also some of the things that happen. So if you're watching us and downloading us from iTunes, go to iTunes and rate us. We would definitely appreciate that. If you're on Dogcatcher or some other place you can get the content, you can rate us there as well. We'd definitely appreciate it. YouTube, you can give us a thumbs up in YouTube and comment in YouTube as well. So a couple of other things. The last couple of weeks, the Google Plus community has gotten a little bit more active. And we are paying a little bit more attention to that as well, and definitely appreciate that. If you're not part of our community, go to techzen.tv and click on the community link at the top. It'll take you right to our Google Plus community where you can interact with other people that are involved in our community as well. So it's a real nice way to get everybody kind of in communicating together, and we're going to try to grow that considerably more. All right, so before I go too far, I want to show you something that I showed you a couple weeks ago, but I want to show it to you working. So let me show you what it is first. And a couple weeks ago, you saw me show you that I had these boards made. And it's an Arduino Uno on the bottom, and these are the 2812 chips on top here. And these are all individually addressable, and basically with this particular design, there's a wire that runs starting here, and then it goes from there to here, from there to here, and down the line. They're all serially connected from an in and out. It's like a shift register typically is, but it's a single chip, and it's an RGB LED. And let me just say, these are very, very bright. So I'm going to plug it in. I have a little test program we're going to look at here real quick. So let's go ahead and plug that in, and you'll see it comes up, and it is very bright red. You see the camera iris is closing down, and it's going to go through a couple different colors, and now it's in the rainbow effect where it's going to do different colors across there. And you'll see there's 3 blank spots. That's because my surface mount abilities must not be very good when it comes to this type of surface mount. I have not gone back and fixed them, but basically I don't think they're getting power, or they have to be getting signal because the signal is passing through them. But my guess is they're not getting power, or it could be the LED is bad, which is another option as well. So, but I want to demonstrate how bright these things really are. So let me come back here, and I'm going to pick this up and I'm going to put it against me. So you can already see it changing my color right there. That is how bright this thing is. You can see how bright it is on the close. So very, very bright. In fact, my eyes are going to be very spotty at the moment because I can barely see. See, I'm going to unplug it because it's like see out the corner of my eye. So yes, very, very bright. But they work very well. I'm already looking at redesigning some of that to be farther apart as far as the chips go, because kind of how I was going to use them was like a light strip on like the edge of a stage and things like that, and that many would be way too bright for that. I can space them out more and use less of them, probably less rows, and get the exact same effect out of it. So something to look forward to in the future. I do have another board coming that is smaller, 1 row, but it's still pretty dense. I need to like probably cut that density down into half. All right, so I also do want to apologize for this week. I was out on Google Plus, and I was going to tweet out and share out this show, and in the process of doing that, I didn't know when I created an event in Google Plus that it would email everybody inviting them to the show tonight. So if you showed up because of that, I appreciate it. But I know a lot of our viewers are not available to watch live because you're in other countries and it's too late outside. So I did not mean to email everybody inviting them. I just wanted to create an event on the calendar so that you would just see it in your Google Plus when you went into Google Plus. So again, sorry for that. I understand some people are not able to watch. So all right, so we're going to take a quick break in the early part of the show, and then when we come back, Bob is going to show us what he's worked on for us for this week. So we'll be back right after this.
You work hard for your business. Your website should too. No matter what industry you're in, select your customizable high-quality design with professionally written content and graphic elements created for your business. Make changes online whenever you like. Switch your background color, page layout, and text anytime. Add your pictures and logo. Upgrade your website with useful one-in-one web apps. And integrate social media. Upload your photo albums and embed videos. With one click, optimize your website for viewing on mobile devices. Choose your free domain, or you can easily transfer an existing one. Thanks to One-in-One's SEO tools, customers can find you everywhere. One-in-One My Website, a professional website created by you.
When you open up an Audible audiobook, it opens up your imagination. Enjoy a steamy romance while ironing the sheets. Discover an historic battle while battling the bulge at the gym. Visit audible.com/freebooks now to try 2 books absolutely free. Get caught up in a whodunit during a do-it-yourself project. Listen anytime, anywhere with the Audible mobile app. When you're out for a walk, learn how to climb the corporate ladder. Or bring a little magic to your minivan with a fantasy novel. With over 100,000 titles, Audible is an amazing experience that you can now try absolutely free. And just like our books, there's no binding. Our great listen guarantee lets you exchange a title you don't like for another. No questions asked. Visit audible.com/freebooks to download 2 books of your choice right now.
But we eventually got it to work. But I've actually run into a different problem with the second. And should we look at code or should we look at video first?
Whichever one you want to.
For the other, okay. Let's switch. Okay, so here we have it's tough to tell. There is a Arduino down here, and there's another one over here, and the one that is connected to the LCD screen, I also have connected to a keypad. So, and I've got several different functions all connected into this, and this is kind of a piecemeal project because you know, I'm trying to answer multiple questions all at the same time, and hopefully when we get done this all makes sense. All right, let's look at the code on the receiver first. So here is the code on the receiving Arduino. And when we get done with the, I haven't commented this as well as I will. So when you're looking at this later and you're downloading the file, you'll see that there's some extra comments in here, but essentially the code will be the same later when you download this. But most of this, we're using the same shifter library that we've used before. However, I did add a function to this. So, and this will be in the data. So I've added this function called setDigit, and all it's doing is it's taking a binary digit and it adds it to the pin output for you, where if somebody goes back and looks at the shifter library itself, what it's actually doing is turning on and off individual pins in a line of shift registers. Well, here it was convenient to have the digits set all in one function. So my library has this extra function that sets the pins for me. So, but this, other than that, they're the same shifter library, clock pin, latch pin, data pin, just like we've used in other things before. I do have an LM35 on here because that was a question that I got asked, is how do you use a radio and a remote control to control a sensor? And what they wanted to do is be able to turn on and off the display of a temperature sensor remotely. So that's what we're going to do. So I've got in the LM35 that we used in a previous demo, and then all of this code right here is to turn, you know, the digits on and off. And then all of this is pretty straightforward. I've got, this is just for debugging. Serial begin, just like before. And then in this one, what we're doing is we're reading in let me get down here. We're reading in, this is where the new code comes in. We read in a code, and what we're expecting is a number, a comma, another number, and a comma, and then a third number. So we take apart the three numbers, and it's an index, a number, and then the total. And then we check, and in this case, I'm only worried about 6 index numbers. 0 through 3, 0, 1, 2, and 3 are going to be the digit number that is on the display. 8 turns on and off the temperature, and 9 tells the shift register to actually write to the shift register. So you can send and receive data all you want, but until you actually tell it to write to the display, it's not going to go. And what you're looking at here, so by the time you get to this line of code, you've got an index number and you've got a value for the number, and it takes those two and adds up those two numbers and then compares it to the total that was sent. And if that is correct, it actually returns total. And we'll see that that actually has meaning here in just a second. If it doesn't, if those two numbers don't add up to total, then it returns a false. And this is how I'm doing data checking to verify that my data is correct. And this is where I had a problem. I ran into a problem where I kept losing data as I was sending data back and forth. Now, when I first read about this, what I found was that it was based on multiplexing, that if you were multiplexing something, then you would end up losing data. And when I started this demo, I actually started with this breadboard because this is I never took this apart. This is the demo that we did on multiplexing 6 or 8 months ago. And I thought this would be a nice display to use for this radio demo. but it multiplexes. And the more I worked with it, the more I cussed at it, and I couldn't get anything to work. So I finally decided to scrap the whole mess and started digging in my spare parts, and ended up coming up with this 4-digit display over here with some shift registers that doesn't use multiplexing. So thought the problem was solved, and then discovered it wasn't. So I ended up having to come up with this scheme to send the total, to double check what was the data that was sent, and then to send the total back. And if the total wasn't right, to resend the data. So it actually became a very convoluted mess, and I was a very grumpy person Saturday when I spent most of my day working this out to get the two radios to reliably send data back and forth. So, all right. So is this making?
Yep, making sense so far.
Making sense so far. Okay. Well, let me switch back to the code for. No, let's look at this first. All right. So you've seen. Hopefully you'll be able to read this. I've turned the data. Now let me turn data on. And what we're going to see is the actual data that's being transmitted and the number of errors that's occurring. So if we look at this, you can see that since I've turned this on, we're in the 350 transmission. There's 360 transmissions, but I've had over 1,000 errors. Were you able to see that?
It's a little hard.
Okay. Well, that's the problem. I have 300 transmissions and 1,000 errors. And unfortunately, this is going by fairly quick. But that's the problem that I was having.
So are you sending it across as a string or as an individual character for each one?
It's just a stream of data. It's a stream of data using the serial print command, which is the standard command.
Right.
And it's only, at most I'm sending 2, 4, 6, 8. I'm sending 9 bytes. And the scheme is an index number, the number of whatever it is I want displayed, and then the total. And then on the receiving side, that's, it's double checking to make sure that the total it adds up is equal to the total it received. And if it doesn't receive that total, then the host resends the data again. So it will keep on doing that until it gets a good number.
Okay.
So now here's where hopefully we can see this. This is another viewer question, or somebody was actually putting together. They wanted to do a remote control scoreboard. So here we can select team A or B, and we add to the score. Oh, wait a minute. This is Seattle. We'll just add a bunch of points all at once. And then we end up with a score, and then we can add to B. Oh yeah, this is Denver. They don't get many. And now you have a remote control scoreboard. And you can, with this simple little scheme that's in the code, you can have time and all the things you need for a scoreboard. You can send with this little setup right here. And this is exactly what one of the viewers was looking for, was how do you put all these pieces together to be able to do this? So, and then the last thing is I've got one function where that's the current temperature. And yes, it is warm with all the lights here at my desk. And just to show that this is real and live, my fingers can warm the temperature up. Of course, it doesn't cool off very fast, but
right.
But it is a legitimate display. I'm not cheating anywhere. So, all right, let's switch to the code. Now, some of this where it's recycled code, I'm not gonna spend a lot of time on it. Now, this one does have a new library called keypad, and I actually got this from this website. So rasmicro.com 25_keypad. Sorry. There we go. So this is the keypad that I'm using. Of course, I'm not using it on Omega, but if you come down to the bottom, there's a link to this keypad.zip, and that's the library that I'm using for it. And it's a nice little library that's already set up for this keypad that I'm using.
That makes it nice and easy.
Yeah, it makes it really easy. So, yeah, because trying to I bought this at my local electronics store, and of course it was in a bin, and there wasn't a data sheet for it. And rather than trying to figure out 10 pins worth of connections, finding the library made it really easy. So, all right, so the LCD screen, that's all. We've used that before, and then I've created a bunch of global variables for me to keep up with the various function keys. The enter key turns on and off the display for the score, elapsed time. That's actually a timing issue, because what happens when you get into something where you're transmitting data back and forth and losing it. This is setting up the keypad, and this is if you go look at that keypad library and their example, this code right there is straight out of their example. I didn't bother changing any of it. And then all of this setup for the 7-segment displays is all code that we've used before. Set up the LCD, set up the radio with the serial connection right there. And then in here, this loop, it actually runs, the Arduino is actually running through this just as quick as it can. And essentially, if depending on what key is pressed, it's just cycling through this as quick as it possibly can. And depending on the function key, it goes off and does something. So if the enter key, this right here is, and I guess we don't need to go through the logic of the code, because depending on what you're looking for, there's 100 ways of doing the scoreboard part, and this was just the quickest, simplest way I could do it. And somebody could do this a lot nicer in displaying the code, or displaying it on the LCD screen. But if enter's on and you haven't displayed this lately, you display this. If you press F0, then you're going to go into the enter new score. If you press F1, then I have this little function called send let's make it, which is what I kept displaying, and it's just a series of characters being sent and setting the display. And if you notice, the receiver was pretty stupid. It doesn't know how to do anything besides display a number, which was on purpose because you want the sending unit to do all the logic. You want all the control there. You don't want the receiving unit having to figure things out, because then that's how you end up with getting out of sync, where the two, what you think you're sending and what's actually being displayed isn't the same thing. So so you never, that's just a little side note that you don't want to.
Right, you just want it to do whatever you tell it to do. You don't want to have to think about anything.
That's right. And then if you press F2, then it's gonna, this is where so it's gonna transmit an 8 and tell it, go turn on the temperature and show the temperature. And then on the LCD, it's gonna show that you're displaying the temperature. And then as soon as it gets through that logic, then it comes right back down here and starts looking through the keys. And right here in the main loop, I'm really not looking for anything other than the 4 function keys and the enter key. And I'm using the enter just to turn on and off the score on the LCD, because I've got too many. I've jammed too many things into one demonstration. You know, if this was just a scoreboard, or it was just displaying temperature, or just displaying text, this would be a lot simpler code. But I've, you know, everything's jammed in here together. So here's the enter the new score. So we're looking at a scoreboard, and we set up a few variables, and we turn the displayed off, because when it cycles back to the main loop, we want that to come back. We want to display the new scores. And we're transmitting this code right here essentially is transmitting back the current score. So we're saying, you know, digit, if you think about the display, digit 0 was on the left, digit 3 was on the right, and they're numbered 0, 1, 2, 3, 4. So in the 0 position, you want the tens character. So we're taking the score, dividing by 10, getting just that number, you know, modulo 10 right here, converting it back to an int, and then this numbers array is the same numbers array that we used before that actually builds the binary code for whatever number you want displayed that goes on to into the shift register. So digit 0, send a number. Digit 1, send a number. And then we go to and then the 9 just says actually push that data onto the shift register. And then we do the same thing right here with team B. We send the two numbers for the team B's score, and then transmit it to push it out onto the shift register. And then we're clearing the LCD, asking for team A or B, and then this little do while loop is going to wait for you to press A or B. And before I get emails about, well, there's better ways of doing this, well, yeah, there is, and this was just the quickest way for me to do this and for this demo. So, and then I make a local variable score, copy whatever team score I've got, and then this section right here is looking for you use the arrow keys to either add or subtract from the current score, and then you press enter, and that tells the loop that you're done. So it'll sit there and go through this, and you can add and subtract all you want until you get the right score. You hit enter, and then you transmit that data back to the display. And then clear the display locally, so the main display will come back and appear. And this is what I've spent. Now, this transmit data function, this is where I've spent most of my the last few days, is getting this to work right. So I set up some variables, and what we're going to do here is we're going to transmit here we go. Where is it? Oh, it's right here. Been through this so many times, I've lost track of where. So I'm using this buffer, and I'm sending it 3 integers, the digit that I want to change, the number that I want displayed, and the total of these 2. And that's all I'm transmitting. And this is what was so infuriating is for this second digit, I never use anything more than the number 255. So that's only 3 bytes. And this integer, I only use 1 character. So by the time you get done with this, you're talking 9 bytes total that I'm transmitting, yet I have a tremendous number of errors, which is quite infuriating. And then this do while loop right here is all, so it transmits that data, and then it waits for a return. And now this actually is kind of important when you're transmitting as back and forth as quickly as we are. This flush command right here makes sure that any data in the outgoing buffer is transmitted before any new data is allowed to be processed. So you never have data collisions this way. And a side note from what I read, this radio has a 200 byte buffer internally. So as long as you stay under, you could send and receive 200 bytes back and forth and hold it in the buffer without overrunning your data. But I'm sending so little data, I don't have to worry about data overruns like that. So we send it, we make sure that the data has been sent, and then we wait for the return, and that return total should equal the total that we sent before. So if one of the two don't work, if these aren't equal, then this good transmission Boolean never gets set to true, and it continually goes through this loop until it receives notice that yes, indeed, it did actually get its data correctly.
And how long will it wait till it times out and sends it again?
There's no wait. Well, I have a delay of 25 milliseconds. And that's it. So I am not waiting for a return, or I'm not waiting any period of time.
Right, but you don't leave that do loop until it gets a return. That's
right.
So what happens if it doesn't get a return?
It'll get stuck in that loop.
Okay.
You know, in the real world, in real production, I wouldn't do it that way. But for this demo, you don't ever want to get past good data. You want to know that good data has been sent before you continue on.
Well, understood. Understood. I thought maybe it would time out and follow through and say, hey, I can get my total back. I need to send it again.
Well, if I was using something, I had intended on doing the same demo where the sending unit was Raspberry Pi. Well, I chased my tail with these radios that I never got to the Pi. But in the Pi, yes, you would actually be able to.
You can do it in Arduino too. You can see if any characters are waiting to be input or not before you actually get stuck in the read routine.
Yeah, you could. But on a Pi, I would do multiple threads, and
yeah, you got a lot more options on the Pi than you do on Arduino.
I'd have a few more options. But in this, yeah, you're right. You could see if anything is actually coming back. In testing this, I was always getting data back. It just wasn't right.
Gotcha.
So that's what this whole mess is for. And then if depending on whether or not this function 3 is turned on, then maybe you display this to the LCD, maybe you don't. Now here we get to the send let's make it, and this is just, we're going to send individual letters, and then the 9 index number just means send it to the display, push the data out to the display, and then we're going to wait a second and then send the next set of characters, wait another second, send the next, and I figured for this demo, sending let's make it was a perfect example. So
yeah, that works good.
Yeah, advertise the show a little bit. And then this last group right here, by sending zeros, we turn the display back off. And then we clear the LCD and continue on. Now this is the same code that I used before. If you reset this is what comes up on the display immediately. And then these last functions, print centered, print right, left, clear row, these are all straight out of the LCD demo that we did before. So now here we are back to the display itself, and just reset it, and we'll reset that one too. What I have noted, one thing I have noticed is that as long as the power never gets shut off, the radios actually stay synced up. So just because you've reset the Arduino doesn't actually reset the radios themselves.
Right.
Which has been a problem because I've had to manually, sometimes I have had problems and had to unplug things. So here we are displaying the temperature, and you could, and it'd be easy right here that if you wanted that data back, you could write a return function to send that data back. I just didn't do it for this demo. And then here we have the data function 3. That's the data screen that tells me how we're doing. So by the time we get done with this, we'll have sent 21. Okay, there are 26 packets of data, and 9 errors in the first 26 packets of data. So,
see, I don't remember getting that many errors when I was messing with it, but I could have been and not realized it.
Yeah, so, and that's why I ended up putting in that display the way I did, is because I wanted to see how many errors I was actually getting. And then, of course, back to the scoreboard, and you could write a much nicer interface than what I did here. But you could, all I'm doing is using the arrow keys on the keypad to send data, and so it's you could write a much nicer interface, but
it's good enough to get the point across the way you're trying to do.
Yeah, it's good enough. And you're not, and the thing about it is that we've talked about the shifter library before, and it's relatively slow. But in this case, you're not in an application like this where you're pushing data across with a radio. You're not going to be sending gobs of data back and forth. You don't need a fast display. So worrying about the shifter library is not something you're going to do. And it'd be very easy right here to have, all of a score, everything you need on a scoreboard, done with shift registers, and just push the data back out. And all you need to know is which digit you're going to, in the software, you've got to know which digit you're updating and which one you're not.
Right. Exactly.
It's not, it's not terribly difficult programming wise to get all of that fixed. So, but everything in there is all, there's really nothing new that we haven't talked about before. It's just putting all the pieces together in a different way.
Right. We've talked about all these different parts and pieces throughout a number of shows in the past. So now they're assembled into something that makes more sense to somebody who's looking for a solution.
That's right. Yeah. A little more, take something simple and make it into something a little more advanced. And hopefully next week I'll have a Pi version of this. Although I've spent so much time with radios the last couple days.
A little frustrated now, aren't you?
I'm a little frustrated.
Yeah, I know that one.
But the small radios that you got a couple weeks ago, I've got coming as well. So
yeah, I'm actually looking forward to getting some time to play with them. I just haven't had time to play with them.
Well, I've wasted a lot of time with these radios.
I've been there.
Yep. But it's, that's the way it goes sometimes. I mean, sometimes you just have to plow through it and beat your head on the keyboard until you get it.
Yeah, I think the thing that was just so frustrating because it didn't work the way it was supposed to work. It's supposed to be, it's described as being so simple, and it's just not that simple. It's
not that simple. Although once the I'm still curious to know why I'm dropping data, and it's not like, it's not like these radios are 100 meters apart.
Right, they're right next to each other, right?
Yeah, I mean the antennas literally are 3 inches from each other right now, so it's not like I've got a signal degradation problem.
Right, exactly.
So, but hopefully this this will help some folks, and putting the pieces together in a new way.
Yep, absolutely. All right.
That's what I got for tonight.
Okay, very good. That's a lot of frustration put into a single show.
Yeah, a lot of frustration into 45 minutes. So.
That's right. Absolutely. All right. Well, we want to thank everybody for watching this week, and we don't really have talked about what we're going to do for next week yet, so we'll surprise you next week. How's that?
There we go.
So we'll talk about it during the week, and we'll figure out something for next week. I got a lot of things sitting around that I can probably pick up in a couple of minutes and keep me ready to do, but throughout the next week, Bob and I will talk. I want to remind you that you can get our shows, if you're not watching live, you can get them from on demand from a number of places. Anywhere you can get podcasts, like iTunes or Dogcatcher, or any of those type of places, you can download our podcast. You can also go to YouTube and watch our shows. No matter where you watch them, we definitely appreciate a rating, and it always helps us get found. And we definitely want to thank all the viewers, because you are helping us get found in different locations. It's definitely growing, and that's all because of you spreading the word around. We definitely want to thank you. We record live every Monday night around 9 p.m., starting at 9 p.m., and go as long as we need to. Tonight, almost an hour. So
Yep.
We'll see you all next Monday around 9 p.m.
Have a good night.
Night. For show notes for this show, contacts, and more, go to the TechZen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku.